Okay, this is a RCA 32-inch LED TV DVD combination. This does have a DVD player on the side right here, and the model number on this set is a LED 32 Charlie 45 RQ, and the TV is pretty much totally dead. We'll plug it in, hit the actual power button on the TV, and that's totally dead, no lights, nothing, no light on the bottom. So it's, as far as I'm concerned, there's no standby lights, so it's totally dead. What I actually do, just to make sure, just to eliminate a fuse or anything, is just actually see if the DVD player will accept the tape. And I'm actually going to put it in there. I'm sorry, we'll accept the DVD, and I think there's one stuck in there already. So, but if it actually did accept the DVD and the TV was dead with no light, that will give you an indication that you could possibly have that like eliminate the fuse, the AC fuse, and what you could possibly have a main board problem. Okay, instead of the power supply. Okay, so let's go ahead and break this baby apart and see what's going on with it. Now on this particular set, once you get all the screws out, you don't have to take the stand off first. You take off all the screws. All the screws are different sizes, so make sure that you separate them. And the actual TV back will lift right up with the stand. How convenient is that? But of course, we do have a few plugs, so don't just yank it off, because you will be mad at yourself for doing that. We have a plug here for the speakers. Okay, we'll disconnect that, and well, light so maybe you can see that. And we have a few other connections here. Looks like this is for the control panel on the side. Okay, so we'll disconnect that one. Okay, all right. Let's see here. Okay, that's the power cord. Okay. And this comes right out. This is for the DVD player. Okay, so that's good. And last but not least, this one here. On this way out, it's been there for a while, so they put some type of, just be careful when you pull it on it, not to pull the wires out. What I'm actually going to do that's going to be better, since it's so stubborn, right? Is I'm actually going to just take these screws out right here. And that way the whole control panel can come out. Hopefully. Voila. We're free. Once again, to verify the model number on this set's LED 32 C45 RQD. Okay. And And so we pretty much have a dead set. Don't know if the DVD's functioning or what's going on with it so far, because these kind of sets can fool you because it has a DVD mechanism which also uses the power supply and main board. Sometimes it could be the DVD player, sometimes it could be the main board, and sometimes it could be the power supply. So the first thing we want to do with it, because of course we have a dead set, is look at the actual power supply. Okay, which is right here. Of course the fuse, which is located right here, is soldered into the board. Okay, it's one of those Pico fuses or funny fuses, whatever you want to call them. So basically what I'm going to actually do is I'm going to see if I have any standby voltage on these pins here. Unfortunately, they are not marked on the board. So I'm just going to go to ground here. Okay. And it's actually good that we did leave our control panel connected. Okay, so because we don't have a remote for it. And I'm going to put our meter here on DC volts. And I'm just going to plug my set in and check these pins here. And see if we actually have any standby voltage. Situated here. Voila, that's better. Just so I grinded my meter on one of these little metal posts down here. You can grind it anywhere. I put it up here so you can see it. That's my ground lead for my meter. Get my meter on DC volts. And I'm looking for either 5 volts or maybe like 3.3 volts. The TV is plugged in. Oops, here we go. What's going on there? Okay. We actually have something jumping around there. Okay. You can see that. Turn this light off. Yeah, worse, huh? Okay. But it's actually jumping around. So what I'm going to do now is I'm just going to put it on max. Now this Agilent is pretty fast, so it may get pretty close to what what actually is trying to get up to. The max voltage. Okay, now what pin was that there? Okay, it wasn't that one, wasn't that? I think it was the third one up, right? Let's see. Here we go. So we're actually getting up to 1 volt. Okay. Alright, let me go ahead and just keep going here. I'll put my meter back on regular. And I just restart it. Okay, so it's the first pin, second pin. Oops, hold on. Okay, it's the third pin. That's the one that's jumping around. Okay, third pin. Okay. I'm just going to keep going here. Okay, now that is not good. That should not be jumping around. It should be, the TV is off. It is plugged in, so it should be a steady standby voltage of, like I said, 3.3. Next pin up. Okay, no. Okay, we definitely have a problem somewhere, right? Okay, yes. So what I'm actually going to do is I'm actually going to unplug the TV, and I'm going to actually unplug this plug here. Going to the, looks like here, we got a couple here. I'm just going to disconnect the main board, because that plug is going to the main board, of course, for your, come on. Alright, that's one there, okay. Alright, and there's another one here. Okay. Okay, just make sure you don't plug this plug back over here, okay, because you won't have any sound. Right, okay. Been there, done that. Alright, let's see here. Okay, we'll just go ahead and unplug this one too, make sure it's not coming through that line. So the main board is completely unplugged from the TV, and when we do that, we should still have a standby voltage once we plug the TV set back in, okay, without it being on at all. We should have standby because there's voltage waiting, standing by to be used, and turn the rest of the TV on. Okay. Let's get situated. Let's go back to those little pins there and see if maybe the main board we had something to do with that. I'll just leave it down. That's better. That's okay. That's better. You can see that. Okay. Okay, we had nothing there anyway the first time. There's nothing there. Okay, we're plugged in. Let me keep going. Nothing there. Whoops. Okay, there we go. Looks like we had something there. I thought so. Let's see. Let's double check. Nothing there. Okay, nothing there. There we go. Got our 5 volts. What do you know? Okay. This is like that was our 5-volt standby, which was being pulled when we had the main board plugged in. Okay. Now, keep in mind, I'm just noticing something here. Okay. First of all, don't assume that it's anything pulling that down. What I'm actually going to do is I'm actually going to go to that 5 volts that we had. Okay, where was we at? Up here somewhere, the 5-volt standby. Matter of fact, where is my marker? I'm actually going to mark that 5 volts. Where are we at? Where are we at? There we go, right there. Okay. Come on, little marker. Let's see, where we go. Okay, anyway, all I got to do is this. I'm actually going to unplug it. Well, I got my hand on there. With one hand, voila. Be careful when doing that, okay? Don't try that at home. And I'm actually going to turn this to resistance. Okay, matter of fact, put it on a diode scale. That'd be much easier to determine if we have a load problem on the main board, right? Okay. And I'm going to start plugging these back up one at a time, okay? Come on, stay in there, stay in there. In there. Okay. That one was being used, okay. Okay. There's something there, but it's not low, right? We want to see if we're going to get like, put it on ohms. Yeah, let's make sure it's not like, 200 or 100 or like 10 ohms. Once we plug one of these plugs back in, because then we know we definitely have a problem with the main board loading that power supply down. Okay, we're still on mega ohms. We got that one in. Still we're missing one. 1, 2, 3. That was it. Okay, that was it. So those plugs are back in. Doesn't look like that's possibly a short or anything like that. So what I did notice, anytime you get a voltage jumping around like that, As a matter of fact, let's go back and redo it. Put our meter back on DC volts. We'll plug in our power. Okay. And we'll go back to where I tried to mark it at right here. Our 5 volt standby. And as you can see, it is jumping around. So, in most cases, when you do what I just did and you don't find any kind of varying resistance, low resistance on the main board once it's plugged in, most likely you have a bad capacitor. Okay, it's charging. It's erratic. Okay, and guess what I seen right here? There we go. Let's zoom. There we go. Bullseye. Bullseye. Right here. I don't know the value yet, but we're actually going to pull it out. Check it. Test it. We know it's probably bad, right? Yeah. No doubt in my mind. And replace it. And that just may solve our entire problem with this unit, okay? I did a video about this, I think on Vizio TV a couple weeks ago maybe. Same problem with the standby line jumping around, bad capacitor. So I see once again in this industry this is getting to be quite normal, okay? Like back in the Samsung days. So anyway, so we'll just pull it out, check it, and then we'll replace it, and hopefully everything will be okay. Okay, we just unplugged our plugs here, and definitely make sure that you unplug the go into the looks like the LEDs there. Four screws. Definitely make sure that you put all these screws back when you reinstall it, especially this one. See, that's metal, that is grounded. If you don't, you might see a little smoke, maybe. Okay. Voila. And there is our nice, let's see if we can read the value on camera here. Oh, it looks pretty. Come on. There we go. 220 at 35 volts. I believe in my last video, that's the same value. To 220 at 35 volts. What was it? I think it was, yeah, it was 220 at 35 volts in my last video on the Vizio B2 series. So, guess what? Hint. Make sure you stock up on those TV repair guys. 220 at 35 volts. Okay, we got our board off. This goes on the bottom. When you mount the board back, that's just a shield, keep it from arcing, so make sure you put that back on there when you reinstall the board. Okay, where's our swollen capacitor? It's right here. Okay, now I did notice that it's a little dark area on the circuit board. That means that it was getting over excessively hot. Which could be normal or could be a problem. So basically what you want to do if you see a problem like that before you start sticking capacitors in there is just check the things around it. I see a diode right here. I'm going to actually check that. Meter and diode scale. Okay. Reading kind of low one way, but I'm going to go the opposite way, and if it reads the same, then okay, well it's infinite. So that diode's probably good. It's probably a one of those Schottky diodes. So we'll go the other way. We'll switch our leads around. I'm sorry, you couldn't even see that. Okay. Okay. And then we'll actually just turn it over. And it looks like in that same circle we got a couple surface mount MOSFETs. You definitely want to check things like that for a short or like a strange region. I usually just go to the tab right here and just As long as you have like a low reading or a short, you're usually fine. Uh-oh. That's reading short there. Okay. Okay, looks like we might have found our problem there. Our main problem. Okay. So we're actually going to I'm going to do it for you right here. This one right here. That is definitely should not be reading or short on all sides. Yep. So actually what I'm doing, I'm actually going to heat gun that out of there. And once we do that, I'm actually going to check it again. Okay. And check the trace. And make sure there's still not a short there. Get some tweezers, that might help, right? That might do the trick. Where do cheap tweezers come from? Okay, my heat and air at about 336, so make sure that you don't want to put it up too high, otherwise the board's going to start puffing up and you may have some additional problems. So I'm trying to zoom in as close as I can here. And baby should lift right up. Right up. Come on camera. Be nice today. Okay. Back where we left off at. This is our effect or diode that was reading short. So we're just going to pull it off and check the transistor or FET out of the circuit, and also check the trace. Turn this heat down. Let me turn the air down a little bit. Voila. Okay, now that we have the transistor removed, I'm going to check the actual traces. Okay, this is it's a trace. We'll remove the FET there, and we're just going to check the trace for a short. Make sure there's still not a short there. Okay. Seems to be okay. And And I'm actually going to check the actual FET transistor that we took out of there. That is a dead short. Yep. Alright, so let's try to get the part number off of here and see if we can match it up with the exact one or something close. Oh, another thing I forgot to show you is that since we found that, we definitely wanted to make sure that there's nothing else around there that looks burnt. I did check the resistors there, that area. Okay. And I'm also going to say this is like a driver or an error IC. Okay, so what I'm just going to do, just to make sure, is check for more than 2 or 3 ground pins and make sure it's not short. I'm just going to ground my meter here. Okay, put it right there. And I'm just going to go across each side here, because that is, of course, as you can see, that is the cold ground, secondary side of the power supply. And one there, maybe. Another one. Okay, that may be okay. Let's double check, see what kind of resistance we got on those ground ones, because that's 0. Okay. Okay, so we'll just accept that. As long as we don't have like a whole side, or like, you know, usually you have like 4 or out of 10 pins that are short at the ground, so that will be indicating that something definitely is wrong. So, so far we'll go ahead and try to match up the MOSFET and the capacitor. And another thing that I actually noticed, maybe I can pick this up on camera, is where are we at? Where are we at? Where are we at? Where are we at? This coil on top, where we're seeing the discoloration on the board right here, L401, okay, and L401, you see the capacitor is EC400, okay, that's the capacitor that's puffed up. We didn't check that out yet, but L401 right here has some bad solder connections. It's actually almost out of the circuit. And also this capacitor has some bad solder connections on it too, the one that's puffed up, and a few other ones. So we're definitely going to touch that up before you can probably see it better now. See how that big ring around there? This also has a ring around here, and the capacitor also has a couple rings. So we got 2 big rings right here. And basically what happened was, from this coil or inductor having bad solder rings around it, it actually arced and blew out this FET right here. Okay, so make sure when you replace the FET that you definitely resolder the coil and any other bad connections around it, because what happens is it will arc and it will short something out which is exactly what happened on this. What probably happened was it was probably cutting off, or sometimes it wasn't coming on intermittently when the customer had the set before she called for service, and she probably just waited until it just blew out. So if she could have called earlier, probably could have caught it, and but it's part of the job, right? Okay, I actually thought I had the part number. I was kind of badly tarnished with conformal coating, so I really couldn't see the part number. But this is what I came up with from what I could see. The last couple of digits was a 5N10, and I came up with this MTE 5N10 on the data sheet. I just Googled the part number, and this is what came up closest to it. As you can see, it's 100 volts, 140 amps, which is really big. But the only thing is, this is actually showing a, if I can find my, a TO220 case, which is much bigger. This is actually a surface mount. So what I did is I just looked at my toolbox, and as long as it's an N channel, which it does say it's an N channel enhancement mode power MOSFET, okay. But of course, something that's a surface mount is probably not going to be that powerful. So I found an N channel 7 amp 60 watt. Doesn't say how many volts. I'm just going to try it in there, and we'll just see what happens, okay? Can't hurt anything. And I did find a capacitor. I'm just going to kind of revise this. This is a 330 at 35. The original one was 220. Okay, I'm just put a little solder on my tip there. Got the IC here, the new one, MOSFET. I'll tack down the pin. And then check down the source there. Okay. And then as far as I'm actually gonna now see how bad this coil is here. Where are we at? Look at that. That is out of the circuit. Okay. That is not good. So we're definitely going to make sure that we get that. This diode here, that's the one that we actually checked earlier. And as far as this capacitor is concerned, I'm just gonna grab one side and just heat up one side at a time. Pull on it, heat up the other side. Pull on it, and it should come right out. take a little wick here and try to clean up the little holes. Looks like there's might not have to. The holes are already there. Okay, that might be a good sign. Make sure you determine which is positive, which is negative. Okay, we'll put the capacitor back in there. As you can see, where are we at? Where are we at? Where are we at? There we go. Okay. Negative side is marked with this little hash here. Okay. Cut off the excess leads. And we will reinstall it back in the TV and see what happens. Okay. Actually, what happened was when I put that other regulator in, the TV did come on, the red light came on, and then when I hit the power button, the red light did change, and so I'm like, yeah. In this particular set, the red light just changes from red to nothing when the TV is getting ready to come on after you hit the power button. It doesn't go from red to green or red to blue like a lot of other TVs. So when I seen it, I'm like, yeah. Then I seen the backlights came on, but guess what? Wah, the backlights went out. Okay, and so I kind of figured, well, I've got the wrong MOSFET in there. I'm just gonna order some, and make sure I got the right one. So I did order some from the little partial part number that I seen. I don't know if you can see, this is the old one here. This is the one that's, and you can barely see the part number because of the little formal code on there. So all I seen was like the 5N10. So I just ordered closest one to it that I seen on Mouser Electronics. I'll leave the link in the description below for Mouser. But what I noticed when I got it was it still was a little bigger than the irregular one. As you can see, this is just the extra one. I ordered a couple of them, but I see I have it already on there, and I'm not going to take it back off because I get a lot of trouble with these other components around here. Some of the traces were actually breaking and stuff, I guess because of the excess heat after I put the capacitor and coil, But yeah, as you can see, the size difference. So come on, baby. As you can see, that one definitely is shorted once again. But the thing is, even though that one was bigger, these legs, I guess that's the driver, the gate, and the, whatever the other pin is, source, drain, right, the gate and the drain pins, they're actually almost the same distance apart. And so what I did, I just put some solder on both of those sides, both of these pins, and then on this part here, I just because it's actually the MOSFET is actually bigger, so you don't have to worry about putting this. I mean, it's not very important to put this heatsink tab all the way down to the bottom. For one, you're probably going to short something out next to it if it's touching, And number two is it's much bigger, so you're not going to worry about that much, heat compensation. Because I'm pretty sure the circuit that this MOSFET was designed in was for a more powerful circuit because of the size of the case. So other than that, I actually did try it in there, and the TV worked the first time, but guess what happened? This coil, remember the coil that was right here that we soldered, that had the bad connections on it, which is right here, one leads there, and right next to the MOSFET. And like I was saying, I'm going to show you one more time about this. When you put this, if you have a problem like this where you get the wrong size, just make sure that you don't short. Come on. That you don't short anything once you lay this down and put some solder on the bottom of that to the circuit board. Okay, but I actually turned the set on and it was playing. I mean, wow! I'm like, wow, okay. So, and then I noticed I started smelling something, almost like burning, like a burning resistor or something. And I'm saying to myself, And then I got close, put my hand actually on this coil, the one that had the bad connections on it, and it actually burnt my finger. This is how hot it was. And that was only after about a minute after the TV was on, maybe like 30 seconds even. I'm like, what the? And what happened was this coil actually started smoking and the backlights cut off. Okay. Alright. So what I did, first of all, as you can see, this is part of the backlight circuit. I'm going to give you a quick rundown of what we got proposed here. We have these two transistors or MOSFETs that are being filtered by this coil here. Okay, the one that had the back, this is actually another one I got off of a nice board here with some much bigger coils. There we go. This is I believe this is a Y sustain or SC board from Panasonic. As you can see, those coils are much more, a little sturdier. So anyway, what I did, I was going to just say forget it and just try to order the board. I thought maybe something else was wrong. But anyway, I replaced it with that coil there. And as you can see, these two MOSFETs, here you go. These two FETs, of course, the tab, it's being filtered by the coil, and it is going to the positive side of the the LED connector. Okay, and it's being filtered or rectified. It's supposed to be rectified through this diode, the one that we checked earlier, and it is going directly to these three pins, which are all connected together. Okay, for the LED driver. Okay, so like I said, I did fire it up after I put this FET in here, and the set came on, played for about a minute, and then I seen some smoke, and this actual coil actually smoked and went out. Now I checked it. A coil is actually, or inductor, whatever you want to call it, actually should read short. It's how it reads, but I can't really check it because I don't have an inductor checker or a coil checker to test the Henry units. It's been so long since I've been in electronics school, but I think it's Henry's as far as the units that you measure it in. Come on. It actually should check short. Okay, just like the one that we have in here. As you can see, I had to modify because the actual leads were too big. So I had to put like some more extra leads in there so I can get into the hole. Okay. So, yeah, so I guess what happened was those connections, those bad solder connections actually, killed this coil. It's probably got a shorted winding in there somewhere. And just killed the coil, and in turn the coil killed the MOSFET, and was overworking the capacitor there. So we changed three things. Okay, I've got this Of course, I did modify the capacitors. I found some now, but I didn't have any 220, so I got 100 and a 150, so it's 250, so that's no big deal, right? And changed this coil. I turned it on, and it played just fine. I watched a whole movie on it. I kept touching this coil. It got a little warm, but just from just from playtime. But it played just fine, no problem. And once again, just to show you the magic of what your eyes can do, just by us checking that black spot here. Remember? See how dark that spot was? And if I look real good up under this coil, it was actually this burn spot here actually started from this coil anyway. So evidently we had a bad coil, okay, or a bad inductor from before, okay, and I just swapped it out and it played fine. Okay, so that's about it, guys. I'm going to put it back together here, and we'll do another voltage check, and I'm going to show you it's working, okay? Once again, remember to put your little black cover back up under the power supply board when you put it back in there. Plug our LEDs back in. Okay, thing looks like it's plugged in. We'll fire it up. Okay, we do have a red LED at the bottom there, and we'll just hit the power button, which of course we still have a control panel connected, so we'll just hit that. Relay is off. Voila, we got backlights. Okay. Turn around so you can see. And right, of course, with my luck, right, we got two vertical lines there. So evidently that has nothing to do with the power supply board or anything that we change. There's actually a bad connection, bonding connection from the driver board to the panel. So only thing that I could do, I'm not going to do anything further with it. Evidently they was watching the TV like that when it was playing, but of course the TV was not coming on, so I didn't know they was there. So yeah, there's nothing you can do with that. Just I'm not going to be going checking the panel loose and all that kind of stuff, because I'm really not charging any money for that. So like I said, guys, we just did a little physical. We found the voltage capacitor on the power supply board. And then we saw the black or charred board, dark spot on the board, and we checked it over and checked some more stuff, and we ended up finding some additional problems, and problem solved. So since this unit does have a DVD player, and I'm going to watch bootleg version. I heard this movie was good. Don't tell nobody I got it though. Alright, you guys, hey, thanks for watching. God bless. Please make sure you subscribe. I will be coming out with some more videos. People want more, so I'm trying to get some time together so I can put more out there. So I really appreciate you guys watching, and all of your comments, and all you subscribers. Big dog out.